Hello, everyone. Today we're going to talk about DNA and how it codes for our proteins. Okay, so this is called gene expression, right? So this process here of making DNA or taking DNA, we haven't talked about this intermediate step here, but DNA codes for protein. So there are two separate steps, this step and then this step. And that's kind of what we're going to start on today. Today, we're just going to talk about this step here, which is called transcription. Okay. This idea of DNA to RNA to protein, that flow of information, is like central to biology and how we get our traits and how we become who we are, or at least as far as our traits are concerned. So let's begin first, since we haven't talked about this thing called RNA here very much. Let's talk about what RNA is and how it's different from DNA. So RNA stands for ribonucleic acid. So RNA, just like DNA stands for deoxyribonucleic acid. They're really similar. So there's three differences that I want to mention here, two of which we'll talk about quite a lot. The first is that RNA is single-stranded. So where DNA is a double helix, like so, RNA is just a single strand, and it has no connecting other strand. It just has just like that. Okay. And then the next thing is RNA does not have any T's. Oh, sorry. This is the wrong one. RNA uses a different sugar than DNA, which for us right now isn't that important. So don't worry about that. I'll mention that later if I need to. And then, sorry, this is the one I was mentioning earlier. RNA has a base called uracil and not thymine. So what I want you to write next to this one is that RNA has A's, it has the letter U, it has the letter G, and it has the letter C. Okay. Whereas DNA over here, don't write this down again, but DNA has A's, T's, G's, and C's. Right. RNA has these four letters, and that's going to be really important for how we go from DNA to RNA. So you're going to need to know that pretty well. There are also three types of RNA, but we're actually not going to write these down right now. We'll come back to these later. Okay. All right. So I want to give you kind of an overview. And so over here, this is not like in any detail, but I split it up into two parts here. So we have DNA to RNA, and that is called transcription. That's what we're going to go over today. But then the second part of it is you take that RNA that you made and you turn that RNA into protein. Actually, the RNA itself does not turn into protein, but we're using the RNA as a message to make a protein. So and that is called translation. All right, so transcription happens here in the nucleus. Okay, so the smaller circle is the nucleus. This is the cell. And so inside of the cell, we should know that this is called the cytoplasm, right? That area inside of the cell, that's not the nucleus, called the cytoplasm. So transcription, what we are doing is we're taking this DNA strand and we're making an RNA strand out of it. We want to keep DNA in the nucleus the whole time because it's kind of fragile, and we don't want any mutations to get to it because that will be bad for making proteins, as you'll see. Okay, so we make a copy of the DNA out of RNA. And then the RNA snakes out of the nucleus into the cytoplasm. And we have this thing over here called the ribosome. Okay, you might recall that the ribosome is the thing that makes proteins. And so how it does that is it reads this mRNA strand that was made in the nucleus. And as it reads it, these little triangles, these little weird little coat hanger triangle things here, they are going to bring these little guys, which are amino acids. So each coat hanger, this is called a tRNA, we'll learn this later, but it brings an amino acid, it brings an amino acid to the ribosome, and the ribosome puts them in the correct order based on, because the ribosome is reading the message down here, it's reading the letters of the RNA. So we are able to put the amino acids in the correct order, which will make our protein, okay? So essentially, DNA becomes RNA in transcription, and then RNA we use to make a protein in translation. So I do have an analogy for this that I want to talk about, okay? So let's say that your great-great-great grandmother um, had a cookbook, a really good cookbook, and she has been handing it down, or she handed it down, and then it has been handed down for many generations, and it finally has gotten to you. And by this point, it's like 300 years old, probably, and it's really fragile. The pages are falling apart, it's like got a lot of wear and tear. So you don't actually keep it in the kitchen, you keep it in the library of your house, maybe just like a bookshelf in a room. We'll call it the library. However, one day you want to make one of the recipes, and so you're like, shoot, I don't want to take this into the kitchen and risk spilling it because this thing's about to disintegrate. So what you do is you take a picture of one of the recipes that you want to use, and you take that picture on your phone out to the kitchen. Now you can gather all the ingredients, and let's say you're making a cake, you put it all together, you put it in the pan, you put that pan in the oven, and then you cook your ingredients, you cook your cake, or you bake your cake, and you now have a cake. That's it. That's the analogy. So let's go over this real quick. Your cookbook, what is that? Nucleus. No, sorry, DNA, right? Your cookbook is the DNA. It's really sacred. You don't want to take it out of your library, which is, bam, the nucleus, okay? So what you do is you make a copy of that. That is your RNA. That's your photo of the recipe. You take the photo out into the cytoplasm, which is your kitchen, and then you use the ribosome, which is maybe, let's say, like the oven, okay? To make your cake, which is the final product, which is a protein right here, okay? So I want you to kind of know that analogy, like that there's so many working parts to that, and it works so well. So actually, let me write this better here. So we got oven, and this is the ribosome, and we got cytoplasm is the kitchen, and we had protein is the cake, and the DNA is the let's say a cookbook, and RNA is the recipe. Okay, nucleus is the library. Bam. So good. Okay, works really well. These individual little pieces right here that we use to make the cake, these are amino acids. Amino acids, that's two words, sorry. Amino acids make up proteins, so those amino acids are our ingredients. Okay, it's a beautiful analogy. Works perfectly. All right, let's keep moving. So transcription, the details. Let's write this down. So DNA to RNA. Okay, so transcription is DNA to RNA. So what happens, I'm just going to break it down to a basic step here. RNA polymerase makes a copy of RNA using DNA as a template. Okay, so DNA does not turn into RNA. We make a copy of RNA using DNA as a template. Okay, so we just read the DNA and make an RNA separate from the DNA. Okay, this occurs in the nucleus. Write these things down. Pause it if you need. Okay. My analogy here is that this is like English to UK English. Okay. So we are going from DNA to RNA. Those things are both nucleic acids. The Na in both of those is nucleic acid. So this is like this. We're going from something that has A's, T's, G's, and C's to A's, U's, G's, and C's. And so they're really similar. Okay, when we go from DNA to RNA, as you'll see, it's not very hard to do. In fact, the word transcription, or we could say transcribe, which has the word scribe in it, a scribe back in the day, they might just rewrite. Ancient texts. If you like wanted to sell a scroll, this is probably too far back, but if you wanted to sell something in mass, you'd have to have people, scribes, recopy that text over and over and over. So they're just rewriting it. That's all we're really doing, is changing it from one to another. We're just rewriting it. So the language of DNA here to RNA is not all that different. And actually, I like this analogy of English to UK English, because if you've seen like how they spell words, like color with a U, so our RNA has U's, which is like British English, which also has U's. Bam. Okay, so we're transcribing something. The next step will be translating, and that really is like a different language. Okay, so let's keep going. Know that analogy. Okay, so here are the steps for transcription. So if you need a pause, you can. So step 1, RNA polymerase attaches and unzips the DNA. So this is this big old glob, this gray glob right here is RNA polymerase. Remember, a polymer is it means many. So we're making a piece of RNA that has many parts, a long chain of mRNA. And so that is this blue thing right here. Okay, we're making this long chain. So what has to happen first is DNA has to unzip or unwind this DNA, or the RNA polymerase has to unwind the DNA. Okay, it has to open it up so that it can actually read the bases here. It has to be able to read what that is, what is that. Like if that's an A and that's a T and that's a G. Okay, so it has to be able to read it. The second step is that RNA polymerase begins to add free RNA nucleotides. So there's in the cell here in the nucleus, there's going to be like little RNA pieces. Like there's going to be A's and U's and G's and C's, A's, U's, G's, and C's just floating around. So the RNA polymerase, this gray blob, is going to take one, the correct one, and it's going to place it here to continue this growing strand. So then this base here on the DNA is an A. So it's going to grab a U and it's going to put a U right here. And imagine this is part of this blue strand right there. And the next thing, oh, there's a T on the DNA. So now it's going to put an A. And there's a G, so then it's going to put a C. And that is continuing this blue strand. So on this side it's opening up. But on this side, the DNA has already been read, so it's closing it and zippering it back together. Okay, so that's the last thing. RNA polymerase RNA polymerase, once it's done, once this DNA strand is all closed up and finished being read, it releases this, and the DNA is all back together in its double helix, and the RNA is released, and it's now free floating in the nucleus, and it's going to go off to the cytoplasm. Okay, so I know this picture is worth 1,000 words, but that means that this GIF is worth some number times 1,000. Depending on the frame rate. So watch this happening here. We'll watch it a couple times. You'll see at the right side, it's opening up. And then at the left side, it's closing down. And the RNA is purple. And it's adding it to it. Okay. Check that out. Now it moves out into the cytoplasm where translation is going to happen. Okay, hold on. We're not going to do translation yet. Let's go back and let's watch this again. So we have the DNA. It starts to open up, and then those little free-floating pieces are put on there, and they're going to continue to be put on. Notice the letters that are matching up. The DNA starts closing on the left side, and it's going to open more on the right side to add more. Add in more, add in more. It's closing up, and pretty soon we have our own separate RNA piece. And the DNA is unchanged, okay? The RNA leaves the nucleus into the cytoplasm. Cool. So let's do a practice problem here. So I want you to write down these letters: ATG, CTC, GGC, AAT. And I want you, and I want to see this in your notes, I want you to write the corresponding letters here. So you should write 3, 6, 9, 12 letters that pair up here. I'll do the first 3. So A, okay. Oh, you know what? Sorry, we haven't done this yet. So A, since RNA has A's, U's, G's, and C's, it doesn't have any T's. So instead of pairing with a T, no, we're going to pair with a U. Okay. However, T always pairs with A. So does RNA have an A? Yes, it does. So T's go with A. Okay. G's always go with C's. C's always go with G's, and so on. Okay. You do the rest of those letters just like I did those ones. So what happens to the RNA strand once it's made? It goes into the nucleus. We just talked about it. And what if there's a mistake made in the RNA strand? Well, it won't be a huge deal. We'll talk about that later, actually. Okay. So, and that is the last thing. Okay. So I know I showed you that GIF, but I'm also going to link some videos that are hopefully they're animated and they're narrated. So hopefully that'll help a little bit better than the GIF. Okay. Thank you. Let me know if you have any questions. Bye.